Hi everyone, welcome to the summary of the second meetup of the Vaughan School of AI. The topic covered today will be Docker for data science. We will be going over why you would use Docker, giving an overview of Docker, and providing you with a practical example. The main point of Docker is to give you a consistent environment that can run anywhere. Within the container, you will have all your libraries and settings set up, and when working with a team, it will make sure that you're all running in the same environment. Whether you're on Windows, Mac, or Linux, code that runs for you will run for your team members. Docker has some similarities to a virtual machine in that it creates a dedicated environment. However, the approach that Docker takes makes it much more lightweight. Docker runs natively and provides an interface for its containers. Meanwhile, a virtual machine wastes a lot of resources by allocating a lot more than your program needs. The virtual machine also needs space for its operating system and other components, while Docker can bypass all of that. The Docker documentation has some great guides on how to get set up and going on your various machines. This video will assume you have had your Docker environment set up, and we will be jumping straight into an example. When getting set up, it's important to know whether you're setting up Docker or Docker Toolbox, which is mostly used when Hyper-V is not available on your Windows machine. All these useful links will be provided in the video description. Now let's jump into our example. You'll want to go to this GitHub repository and either clone it or download the zip file and then extract it. On Windows, make sure to place all your files inside one of the user's folders, especially if using Docker Toolbox, to avoid any permission errors later down the line. Here I am using Commander, but any console or Git visual tool will work to clone the repository. You should change the directory to where you want the repository to be placed, then copy the link and clone the repository. After waiting for a moment, the repository should be cloned and you can cd into that directory. Take a look around once you're inside there to see what files you have to work with. Once you're inside the repository, you can run Docker commands straight from your console. However, if you have installed Docker Toolbox instead, then you will need to run the special Docker Toolbox console. If you are using Docker Toolbox, once it has started up, you will want to change directory to wherever you have your repository set up. Now you're ready to build your Docker image. The Docker image is what defines what will be inside your container. It determines your environment. You can pick one of these three commands to run. I recommend picking the first command as it will build the full Docker image on your system. The second option is to pull the image from a Docker repository instead of building it locally. This will make sure that you have the full image on your machine. The third option is to download the light version of the image. This will not have NLTK included, but it will be beneficial if you have a slow internet connection, and you will still have access to TensorFlow within the Docker image. Keep in mind that each of these options has a slightly different image tag. As you can see, the first image has the tag Jupyter Stacks TensorFlow. However, if you were to go with option 2, whenever using the tag, you would have to write nikitavr/Jupyter Stacks TensorFlow. Before building the image, let's take a look at our Docker file. The Docker file is what determines how the image will be built and what will go inside of it. The first line of this Docker file shows that we will start by using a different image. We will be using the Jupyter TensorFlow Notebook image and building on top of it. This image, provided by the Jupyter team, takes care of creating an environment where we can run Jupyter notebooks and supports TensorFlow. The two run commands take care of installing NLTK and downloading all of the NLTK data so that we have something to play around with. Finally, the copy command copies all of our files from the examples folder into the examples folder located within the Docker container. You don't need to worry about this username within the Docker container. It is simply the username of the original user for the container. Now let's build the image. Since I have built the image before, Docker remembers all of the layers that have been used, detects no changes, and goes ahead and completes very quickly. Now we can run our container using the docker run command. This command here will run the container on port 8888 It will make sure that Jupyter Labs is enabled, which is an advanced Jupyter notebook, and it will also make sure that we mount our folder labeled mount. What this does is it makes sure that our local files are available within the container. Any changes done within the container outside of that mount folder will not be persisted if the container is shut down. If you're running Docker Toolbox, you'll need to make sure to run the Docker machine IP command. This will get the IP of the virtual machine that Docker Toolbox uses. The virtual machine is used by Docker Toolbox to run when your system does not meet the minimum requirements. We can now run the container. Once the container starts, it will also start a Jupyter Notebook server. Once the server starts, you can copy the outputted URL and go to your browser. Once you're in your browser, you can either use localhost if you're using regular Docker, or you will have to use your Docker machine IP if you're running Docker Toolbox. Once you enter the URL, you'll be taken to the Jupyter Notebook environment. Inside, you should see the copied over examples, the downloaded NLTK data, and the work directory. Any work that you want to be persisted should be done inside the work directory, as it is the only one that is mounted and will persist on your file system once the container is shut down. You can now go ahead and take a look at some of the examples. The example shown here is the classic MNIST image prediction, where you have to predict handwritten digits. Once you run the Python notebook, this will download the MNIST dataset, then it will train your model, and at the end it will run predictions on the test data. In summary, Docker is a lightweight container solution. It creates a consistent environment to ensure that code runs predictably. It is great for data science and AI projects where traditionally a lot of environment setup is required. It also makes collaboration easy because all of your team members are running in the same environment and the code that runs for you will run for them. I hope you found this video informative and you can ask any additional questions in the comments below. Follow us on social media for more AI related content and visit the School of AI website.